This is an intro to statics, and my name is Ryan Varner. Today we'll be discussing statics. First, what it is. Secondly, the history of statics development. And last but certainly not least, some key concepts or principles used in statics. Of course, statics is an introductory engineering class, so I would say it could be beneficial to review physics, calculus, and trigonometry. Now that being said, you really don't need to review them before this video, but certainly as you delve into more and more complex problems within the subject. So let's get to the interesting part. What is statics? Well, as you can see, there's elementary mechanics, and elementary mechanics can be broken into three subcategories: rigid bodies, deformable bodies, and fluids. They can be broken up even further into statics and dynamics under rigid bodies, mechanics of materials under deformable bodies, and incompressible or compressible under fluids. So statics is the study of objects in equilibrium. And as we can see from the tree, it is a rigid body in equilibrium. What this means is that the sum of the forces in the x direction will be 0, the sum of the forces in the y direction will be 0, and also the sum of the forces in the z direction will be 0. Likewise, the sum of the moments around each axis will also be equal to 0. This is opposed to statics' cousin dynamics, which is concerned with the accelerated motion of bodies. So we can now see that if the sum of the forces did not equal 0, there would be an acceleration in some direction, and we would then be discussing dynamics. We could actually consider statics to be a special case of dynamics where the acceleration is 0. However, statics gets its own engineering category since many objects are designed with the intention of remaining in equilibrium. So where did statics come from? Well, statics was developed early in history due to the fact that its principles can be easily formulated from measurements of geometry and force. To show how early, writings by, and excuse me if I'm wrong, Archimedes, dated 287 to 212 BC, deals with the principles of a lever. Studies of the inclined plane, wrench, and pulley were also recorded in ancient writings. If you just so happen to think, gee, why are these guys only studying objects involving architecture? It's because at that time, engineering was used primarily for building construction. Of course, due to the necessity of an accurate measurement of time, dynamics was developed much later. Galileo was the first main contributor to this field, experimenting with pendulums and falling bodies. And of course, how could we forget Isaac Newton, who formulated the three fundamental laws of motion and the law of universal gravitational attraction. Now that we know what statics is and where it came from, we need to know how to start solving a statics problem. The basic quantities are a good place to start. There's time, length, mass, and force. Length is used to locate the position of a point in space and then describe the size of a physical system. Time is a succession of events. Although the principles of statics are time independent, dynamics relies heavily upon time. Mass is a measure of a quantity of matter that is used to compare the action of one body with that of another. Force, in general, is considered a push or pull exerted by one body on another, and can occur through direct contact such as pushing on a wall or through a distance when the bodies are separated, such as gravitational attraction. Either form force takes, a force is completely characterized by its magnitude, direction, and point of application. Because statics is the study of a rigid body in equilibrium, it would be important to know what a rigid body is. A rigid body is essentially a large number of particles, and these particles remain a fixed distance from each other, both before and after applying force. This is important because if the body does not change, we can neglect what material the body is made out of. In most cases, deformations occurring, say something such as a structure, are so small that the rigid body assumption is suitable for analysis. And you can see from these great pictures I've created, the particles do not move after the force is applied. The last concept we'll be going into detail is Newton's three laws of motion. The first law states that a particle at rest or moving at a constant velocity tends to remain in this state provided the particle is not subjected to an unbalanced force. From the picture, you can see that the sum of F1, F2, and F3 must be 0 for the particle to remain at a constant velocity and direction. The second law states that a particle acted upon by an unbalanced force experiences an acceleration that has the same direction as the force and a magnitude that is directly proportional to the force. This is where the equation force equals mass multiplied by acceleration, or F equals ma, comes from. The third law states that the mutual forces of action and reaction between two particles are equal, opposite, and collinear. So, in summary, we can say that statics is the study of bodies that are at rest or move with constant velocity. A particle has a mass but a size that can be neglected, and a rigid body does not deform under a force. A force is considered as a push or pull of one body on another. Concentrated forces are assumed to act at a point on a body. Newton's 3 laws of motion should be well known. Mass is a measure of quantity of matter that does not change from one location to another. Weight, however, refers to the gravitational attraction of the Earth on a body or quantity of mass. Its magnitude depends upon the elevation at which the mass is located. In the SI system, the unit of force, the Newton, is a derived unit in which the meter, second, and kilogram are the base units. And you should perform calculations with as many significant figures as possible and then round the final answer to 3 significant figures. Make sure that the equation remains dimensionally homogeneous, or that the units of time, mass, and force cancel correctly and remains within the same system of measuring, either SI or US customary system. So, now we know what statics is, where it came from, and the concepts that define it. Before you know it, you'll be analyzing things in everyday life with statics. For some reason, I'm not really sure why, but I particularly like to analyze cranes, but that's just a side note. I'm sure everyone has their thing they like to analyze. I do hope you have more knowledge on statics or even physics or mathematics in general than you had before watching this video. We'll dive more specifically into statics in further videos, and happy learning.